Okay, so in this video, we're going to look at how to loop through a dictionary as well as look at generating random numbers. So, as I mentioned earlier in a video on dictionary, you have to include or use the word include using data structures. So, a dictionary is implemented as part of data structures. So, this using is a keyword that you have to include here and then write the data structures. That's the name of the package. Now, again, assume that you would have already run this Julia command for importing all the packages, 0_import_packages.julia file that will import new packages as well as be updating the packages that are listed in that file. Okay, so in the dictionary video, we saw the three ways of creating a dictionary, just using dict and then an ordered dict and sorted dict. The dict, let me just pull it up. So the dict version is not guaranteeing you how the keys will be stored in it. So the keys inside the dictionary will be stored in a random order. So it may not be the same order you're inserting to the dictionary. If you want to retain the order in which you are inserting the keys in the dictionary, you have to use the ordered dict. And then if you want the keys to be stored in sorted order so that you can retrieve them also in sorted order, then you have to use sorted dict. Okay, so I'll just show you in this video how to loop through a dict as well as a sorted dict, and similar approach can be also used in an ordered dict as well. So here I just manually create a dict object, dict1, and in it I insert 4 keys with values correspondingly floating numbers. So the keys are 1, 2, 9, and 5. So I'm including the keys not in a sorted order, in some arbitrary order. Okay. So now what I want to do is I want to loop through this the dictionary and retrieve the keys and print them in a sorted order. Okay, so I want to print the keys of this dictionary in a sorted order. So what I could do is then now we saw in the earlier video again the keys function. If you pass it to it the dictionary object dict1 in this case, it will retrieve the set of keys in that dictionary, and you can pass that key set, the set of keys, this one, to the collect method that will organize those keys as an array. So the collect method will return an array of the keys. Now you could call the sort method on that array and get the keys sorted. Okay, so you basically now have a sorted array of the keys in the dictionary dict1. And then you can loop through it by doing like this. For I in the sorted order of the dictionary keys, you can print that I. Now, if you want, you can add something like this. Let's say dict1 of I. So you can print the corresponding values as well. Okay. So let me run through it and walk you through the output. Okay, so let me use a println statement here that it's readable. And this is our understanding, so I can put an imply sign to show the mapping of the key value pair. All right, so now I'm basically able to print the keys in this dictionary dict1 in a sorted order, and I'm also able to retrieve the corresponding values. So the values could be retrieved using the dict1, the dictionary object name, and then we pass the key as the index to that, so that you retrieve the value. Okay. And then what I want to do here is I basically want to store what I just printed, this stuff, because this is a sorted order of the keys. So I want to store this in a sorted dictionary, another dictionary, which is a sorted dictionary. Now you could do it here itself. So let me do that here. Sorted, let's say, sorted dict Means what name I'm giving here. Dict2. I can say sorted dict1 equals. So you can say sorted dict off. So this is creating an empty sorted dictionary. Okay, it's creating an empty sorted dictionary to which you can push these stuff. Okay, so that's what I'm doing here as well. No, we cannot push. We can push only to a vector. So we can do it like this. Sorted dict1, that's the sorted dictionary. I can add an entry by directly indexing to it, and then I can say dict1 of I. Okay, so that would basically add an entry to the sorted dictionary. So we could print ln sorted let's print the contents of the sorted dictionary 1. Yes. So it's storing the keys in the sorted order 1, 2, 5, and 9. Okay. So this is how you could do it. So you could create an empty sorted dictionary. The sorted dict is the keyword on the right-hand side. So that's going to be on the left-hand side, the sorted dict1 is then a sorted dictionary. To that, you could add the key value pairs like this. So I could add the key I, which is basically retrieved from the sorted array of the keys. And I could, as I'm accessing the value for that key in dict1, I could do the same thing here. I could say equals dict1 of I, so that value gets added to the key in the sorted dictionary. Okay, and I can eventually, coming out of the loop, print the contents of the sorted dictionary. Now, that's one way to set up a sorted dictionary based on the key value pairs from the ordinary dictionary. Now, the other way to run a loop and extract the contents of the dictionary 1, dict1, which is a random dictionary, is to use kind of like an enumeration approach. So we can use a for key comma value in dict1 because dict1 stores the contents in a sorter, not in sort, in a key as a key value pair. You could extract as a key value pair itself like this, and you can print it if you want. And the same thing I'm doing here. So let's make it a sorted dict2. And you could add to that value, and you can print that is here as well. Okay, so you could extract things as a key value pair and then use that key to index into the sorted dictionary 2 and add the value to it. Okay, so let's run it. So it's going to be the same thing, the same sorted dictionary. Okay, so that's about using sorted dictionary, looping through a dictionary. And so I added a piece of code after the video I recorded for the loops file number 12. So I stopped with this A8 array, which comprises of the squares of the prime integers from 1 to 100. Now, remember in this video on this loops number 12, we also saw a map function. I can show here. So you have an array A4 that has these 4 elements. And this map function basically has the syntax. On the left-hand side of this kind of implies sign, you have, or you can say instead of implies the arrow sign. The arrows on the left-hand side of the arrow sign, you have a variable x that will be used to loop through the array, which is listed here. And then on the right-hand side of this arrow sign, you have kind of an expression, like in this case, x squared. So the x will be subjected to x squared, and the values of x squared will be filled in this array A6. So that's how this map function works. So the values in A4, which are retrieved as x, are kind of squared based on the expression on the right-hand side of the arrow sign, and those values are filled with in A6. Using the same logic, what we could do is, I want to create kind of like a Boolean array A9 that has either a 1 or a 0, 1 corresponding to a true and 0 corresponding to a false. In the sense that if the entry for an integer or for an index, for example, if an entry for an index is 1, that means that the integer corresponding to that index is indeed prime. If the entry for an index is 0, then that index is basically not prime. So I want to basically create a Boolean array of, say, size 10 that represent indexes 1 to 10. And I basically want to have ones and zeros. 1 if the corresponding index is a prime integer, and 0 if it's not a prime integer. So I could pass and create an array like A4 separately and then pass it to the map function. But since I know the index range, I could call the collect right away, and that would generate an array from 1 to 10. So that's the array. And this I is the index variable that we will index onto that array from 1 to 10, this array. And the right side expression for this arrow sign is, in this case, remember we have an isPrime function in this code that returns true if the number that you're passing to that function is indeed prime, otherwise it returns false. So I can call this isPrime function to which this I is passed. So the return value, true or false, will be that value that will be stored in this A9. So my A9 is essentially a Boolean array that will have ones and zeros. Okay. And the corresponding indexes will be either accordingly prime or not prime. Then once I generate such a Boolean array A9, I could loop through that array A9 and check the entries in that A9 corresponding to those indexes. And for that, I could make use of this enumerate function. So enumerate, we saw also in this video on file 12, that when you enumerate through an array, say A2, it returns the index as well as the value at that index. Okay, so in this case, we can enumerate through A9 and get the index and the value at that index. Now, this is basically a comprehension approach where you have some index variable and then a for loop to run through that index, and then a condition. Okay, so let's look at this middle part here, the for loop. So the for loop will enumerate through that Boolean array A9, retrieve the index value and the true or false, which will be that X corresponding to that index. Then I want to only store the index value in A10, provided that X value corresponding to that index is true. So the X value corresponding to that index will be true if index is prime. Otherwise, the X value will be false. So if X is false, the condition is false. So I won't be storing that index to A10. So only if this condition X is true, then the whole condition for this if block will be true, then this index will be getting into A10. And what indexes is basically the integers from 1 to 10 that are indeed prime. So if you run it through the file here, you will notice that happening. So A9 is basically a Boolean array of ones and zeros, and then A10 will be storing only the indexes retrieved from A9 based on this enumeration approach, and it will have only those prime integers. Okay. Just wanted to show. So just try to understand it. It's kind of looks complicated, but I want to illustrate the different ways of using this functions and approaches to comprehension and this mapping and all these things. Okay. All right, let's look at code 14, which is how to generate random numbers in Julia. So for that, you need to include this random package. So I will say using the keyword and the random. So that 0_import packages file has that random package as well. That's the first one actually in this list. And then the data structures. So after 14, the next set of files we're going through are like linear algebra related to matrices. We'll do that this next videos after this. All right, so let's finish this random number file. Very simple syntax is rand. So the function is rand to generate random numbers. And if you just pass one argument to it, that will be like a number indicating the number of random integers, or not integers, the number of random numbers that you want to generate from 0 to 1. So that they'll be float. Okay, sorry, I said integer. So it will be basically the number of random numbers you want to generate from 0 to 1. If you just pass one value, that will be the length of that array. So it will be generating an array or a vector of random numbers from 0 to 1. And I'm calling that as storing that in a rand vector. Let's run this simultaneously to look at the output. Okay. So this will be this, I'm not printing this in a formatted fashion. You could use the printf statement that you saw earlier to try to print this in a formatted fashion if you want to. But the focus here is on generating random numbers, that's it. All right, so as I said, all the numbers will be from 0 to 1 in rand vector, okay? So now, sometimes you may want to generate random numbers in a certain range. So if you want to generate random numbers, let's say from 100 to 1000, so the starting number has to be at least like 100. It could be 100.05 or anything like that, but cannot be less than 100. So the goal is whatever this, again, let's say you want to generate 10 numbers from 100 to 1000. So I have already generated the rand vector that has 10 random numbers from 0 to 1. So I want to kind of scale it up to a range from 100 to 1000. So the way I will do that is, I'll multiply every element in this rand vector by this term, which is basically telling, okay, so there are how many what do you call the range here from 100 to 1000, okay, is going to be 1000 minus 100 plus 1. So I want to compute kind of like the length. Again, we are generating real numbers here, but we want to kind of get a stretch of that range from 100 to 1000, and that is this. Okay, so I want to multiply each entry, each element in that rand vector, which is from 0 to 1 by this. So that would scale things to a range of 0 to 900. Okay, because this is from 0 to 1. So if you multiply this, the number inside is 901. So since this is less than 1 here, at most you could get is 900. And the minimum you could get is 0. Okay, because if you have a random vector that is 0.0 something, it will be multiplied by 901, could be still 0.0 something. So to that resulting value, you're adding a 100. So as I said, the minimum that you could get on the second term is like 0.0 something, plus this 100 will be some 100.0 something. And the maximum you could get was 900, and plus this 100 would be 1000. So that will make the random numbers to be in a range from 100 to 1000. So this is kind of like a formula you could think. So if you want to generate random numbers in a range from, say, A to B, again, this is inclusive. It could be starting from A all the way up to B. Then you generate random numbers from 0 to 1. I will indicate like that. Let me do it like this. Rand vector, that will make it easier. So rand vector is from 0 to 1. And multiply an element in it. So this is like the dot operator by the difference in the age b minus a plus 1. And to whatever the result of this, that's the second term for us, you will be adding a. And you'll be doing this for each element in the rand vector. So you're doing a dot plus. Okay. So this dot operator is, as a name, is called the broadcasting operator. The reason why it's called the broadcasting operator is once you include the dot, like here, you are doing that accompanying operation, which is in this case multiplication, to all the elements in that vector. Similarly, once you include the dot plus, you're doing the addition to all the elements to that vector. Okay, so that's why it's called the broadcasting operation. So you could print then the rand vector 1. So this element is basically multiplied by that 901, and to that you're adding a 100, and that has resulted in this number. So you do that for each element in this rand vector, and this is our rand vector 1 that is now in the range from 100 to 1000. Okay. Now, let's say I want to generate 10 random integers. So in the earlier case, I generated 10 random real numbers in the range from 100 to 1000, and you could do it in this fashion. Now, if you want to generate 10 random integers in the range from 100 to 1000, there's a way to do that. So you specify, so the first case, you just pass one argument to the rand function that corresponds to the number of random numbers you want to create from 0 to 1, and then you scale it up using this approach here. Now, for integers, for generating random integers, you have a straightforward function that will take two arguments for the rand function. The first one will be the range within which you want to generate the integers. And the second one would be the number of such random integers you want to generate. So you will be generating then 10 random integers in the range from 100 to 1000. So that's what this output is showing. So these are the 10 random numbers, integers, 10 random integers we have generated from 100 to 1000. Okay, so let's stop the video with this.